4.3 Day 1 Right Triangle Trigonometry. We're going to evaluate trigonometric functions of acute angles, use fundamental trigonometric identities, and then use trig functions to model and solve real-life problems. So remembering the 6 trig functions, we're going to look at a right triangle in particular. Consider the right triangle shown in which one acute angle is labeled theta. Relative to the angle theta, the 3 sides of the triangle are the hypotenuse, the opposite side, and the side adjacent of the angle theta. So using the lengths of these 3 sides, you can form 6 ratios that define the 6 trig functions of the acute angle theta. So we're looking at theta, which is between 0 and 90 degrees. So looking at these right triangle definitions of trig functions, we can remember that sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Or you can think about it as the SOHCAHTOA. And then the other 3, cosecant, secant, and tangent, are just the reciprocals of the ones above it. So let's use these ratios to evaluate the 6 trig functions given a triangle to the right. So we have sine of theta, cosine theta, tan of theta, cosecant theta, and secant of theta, and cotangent of theta. So we know 3 and we know 4, and then so we need to figure out the hypotenuse. So in order to find that, we know that the hypotenuse is our c value. And remember the Pythagorean Theorem. A squared plus b squared equals c squared. So we can plug in what we know. 3 squared plus 4 squared equals c squared. And we will have to take the square root. So this is going to be the square root of 9 plus 16. Or c equals 25. Now, normally this is a plus or minus, but because we're dealing with measurements, it's only a positive value. So when it's not c equals 25, the square root of 25 equals 5. So c equals 5. So we fill this out. So sine is opposite over hypotenuse, so that is 4 over 5. Cosine is adjacent over hypotenuse, so that's 3 over 5. Tangent is opposite over adjacent, which is 4 over 3. Then we just know the cosecant is a reciprocal of sine, so it's 5 over 4. Secant is a reciprocal, so it's 5 over 3. And cotangent is 3 over 4. So go ahead and try this example here. Use a triangle to find the values of the 6 trig functions of theta. So you're given the hypotenuse and the side opposite. So find the side adjacent and then evaluate these trig ratios. Make sure to rationalize the denominator if you need to. So if you tried this out, you would have found that the side adjacent is 2 root 3. Now, I don't know if you could tell what type of triangle this is, but maybe you can. And so this, I can tell, is 60 degrees. I know that because the shortest side is 2, the hypotenuse is 4, which is double, and then the side adjacent is 2 root 3, which is our 30, 60, 90 triangle. And so if you take a look at what sine is 2 over 4, or 1/2. Cosine of theta is root 3 over 2, because you have to rationalize the denominator. Then tangent of theta is root 3 over 3. And so if you notice, this is actually, this should remind you of the values of the unit circle. Let's take a look at example 2, evaluate trig functions of 45 degrees. And so we know 45 degrees is also pi over 4. So you may not need to even make the triangle, but you could draw the triangle if you need to and then fill it out. So we know it makes this triangle here, right triangle. We know this is 45, 45. And then let's just call the sides 1. And to get to the hypotenuse, that is square root of 2. So I know sine of 45 degrees is just root 2 over 2. Cosine of 45 degrees is also root 2 over 2. And tangent is opposite over adjacent, which is just 1 over 1. So the answer is 1. So see if you can go ahead and try to evaluate the values of cotangent of 45, secant of 45, and cosecant of 45. Try it out. So if you try this out, you know that cotangent is just a reciprocal of tangent, so it's just 1. Secant of 45 degrees is root 2, and cosecant of 45 degrees is also root 2. Let's take a look at this final example. Use the equilateral triangle shown to find the values of sine of 60 degrees, cosine of 60 degrees, sine of 30 degrees, and cosine of 30 degrees. So you can think about SOHCAHTOA. But you can also just know the values of the unit circle. That may be able to help you out if you have those memorized. If not, you can go ahead and use the SOHCAHTOA to kind of help you out with these. So we know that sine of 60 degrees, that is opposite over hypotenuse. So that is square root of 3 over 2. Then sine or cosine of 30 degrees. Cosine of 60 degrees. That is adjacent, 1 over the hypotenuse, 2. Then we think about sine of 30 degrees. So we're looking up here. That is opposite, 1 over hypotenuse, which is 2. And then cosine of 30 degrees, which is adjacent, root 3 over hypotenuse is 2. Now go ahead and try this last example here. Find the values of tangent of 60 and tangent of 30 degrees. So tangent of 60 degrees, if we're looking down here, that's opposite root 3 over adjacent, which is 1. So that's just square root of 3. Tangent of 30 degrees, so we're looking up here, that's opposite 1 over square root of 3. Then to rationalize the denominator, you see that as root 3 over 3. Okay, so you have some examples of these for homework. Try it out.